Okay. Chapter 8, test review. I'm going to tell you right now, there's a lot of junk on this test. Does anyone know what I mean by that?
Useless stuff.
There's a lot of useless information that you do not need. Okay, so what I want you to do on every single problem, especially the ones on the back, okay, read the question first. Because most of the time, if you read the question, you don't need to read everything else. Okay, so on this one, if I read this, it says, what is the horizontal distance of the ramp in inches? All it wants us to do is find this. Did I need to read anything else?
No.
No. Okay, if I know two sides of a right triangle, what can I do to find the third? Pythagorean theorem. Okay, why I think some of us get this problem wrong sometimes. Why do you think?
Because we don't put the hypotenuse, we do it wrong.
Bingo. Where does the hypotenuse have to go? Has to go with C. So if I plug this in the correct way, we get 12 squared plus x squared equals 144 squared. If you don't have it set up that way and you have 144 on the other side, you will get it wrong. Okay? So evaluate, what's 12 squared? 144 plus x squared equals 20,736. What do I do from here to solve? Subtract 144 on both sides. Whoa, too many. So we get x squared equals 20,592. Last step here, always square root. Every last step in the Pythagorean theorem is going to be the square root. So you should get x equals 143.5.
Can you round it up?
No.
Oh, I rounded it up.
On the test, and I made sure for the test, I know it wasn't on the review, but for every single direction on the test, I'm always going to have you round to the nearest tenth, just to keep it consistent. Okay? So every single time you do this, any question on the test, round to the nearest tenth.
It's giving me this.
On this test, there are multiple ways you can check if your answer makes sense. Okay? Plug this back into here. Does it make sense that that side can be 143.5?
Yeah.
Okay? Let's say I got 160 for that.
No.
Would that work? Why not?
Because it can't be bigger than the hypotenuse.
Can't be bigger than the hypotenuse. Okay, so use your best judgment on those. Check your answer if you need to. Okay. All right. Number 2. What do I want you to read first?
Directions.
The question, right? Says, will the side lengths form the shelf? Right now, do I know anything about the shelf? No. So I need to go figure that out. In this case, it tells us the shelf is a right triangle. Okay, so how do I know if 3 side lengths make a right triangle? Pythagorean theorem again. Yep, so a squared plus b squared equals c squared. What is always going to go where c is? The biggest number. What's kind of nice about these is they have them listed for you least to greatest. Okay, so I'm going to do this example with you. So we have 9 squared plus 40 squared equals 41 squared. Some of you might get lost because there's no variable in there. You just keep evaluating. What's 9 squared? 81. 40 squared is 1,600, 41 squared is 1,681. What's the last thing I can do here? Yeah, we just add this side together. So we get 1,681 equals 1,681. Now you ask yourself, is that a true statement?
Yeah.
Yes. 1,681 equals 1,681. So yes, that will make a right triangle. I'm not going to show you the other two for sake of time, but for this second one, you end up getting, it is going to be no, you end up getting 3,721 equals 3,844. Is that a true statement? No. So that is when your answer is no. Number 3 and 4, we are finding the missing side lengths of triangles. What should pop out to you on these?
45.
Yeah. Am I going to give you this diagram? Unfortunately, no. Okay, this is something you have to memorize. So I have 45, 45, 90. What do I know about those?
2 sides are equal.
The 2 legs are the same. Okay, and then how do I get from leg to hypotenuse?
Square root of 2.
Yep, it's going to be square root of 2. Am I going to use any other number? No. So if I'm going to the hypotenuse, I'm multiplying. If I'm going back, I am dividing. On 3a, does it matter out of a and b which one I find first?
No.
No. Why not?
Because of this one.
They're going to end up being the exact same thing. So how do I go from hypotenuse back to a leg? Yep, we're getting smaller, so I'm going to divide by that square root of 2. So I'm going to take 3 divided by square root of 2. How do I simplify that? multiply by square root of 2 on top and bottom, whatever that bottom radical is. Multiply straight across. What do I get on the top? 3 square root of 2 over square root of 4, which does ultimately turn into, yep, square root of 4 turns into 2. With division, what do you have to check last? If you can simplify these. Okay. Do I want you to have decimals for these? No. Don't have decimals for these. How you write your answers on these. I don't care. You can pick one of two ways. Put your answer up with the picture, okay, in the correct spots, or you can come down here and write A equals 3 square root of 2 over 2, B equals 3 square root of 2 over 2. Or if you're here, this equals A and B. I don't care, as long as you tell me what goes for what side, okay? B. So, on B, does it matter if I find X or Y first? Right, I would want to find Y first because it's the easiest, right? What do I know about this side and this side? They're the same. So I know that Y is 3 square root of 5. Easy. Okay, how do I go from the leg to the hypotenuse? Bingo. 3 square root of 5. I'm getting bigger, so I want to multiply by square root of 2. Quick review. Can I combine the whole numbers with the radicals? No. Okay, this just turns into 3 square root of 10. Can I, you always want to check if you can simplify. Can I simplify that? I can't simplify the square root of 10, so my answer is here. Remember, please specify what side that is for. Okay, yes, on this one, what should jump out at you is that 30, 60, 90. Okay, so here's the model. What is the most important side on 30, 60, 90? Short side is the most important. That's the one you always want to find first. How do I go from short leg to long leg? That one's the square root of 3. How do I get short leg to hypotenuse? Times 2. I always remember that because the hypotenuse is the biggest side. So it would make sense to double that side. Okay. So number 4, I'm going to ask you this. Is it a nice problem or a gross problem? Why is it nice? It gives you that starting point. It gives you the short leg. So I don't really have to do any going backwards. Okay, so does it matter if I find M or N first? No, I'm just going to find M first. How do I go from short leg to hypotenuse? 5 times 2 is 10. And how do I go find N? From where? Yes, so 5 times square root of 3 is 5 square root of 3. Now, if I left my answer like this, could I give you full credit for that?
No, because you don't know what side we're talking about.
You have to specify what side you're talking about. Okay, so again, you can come up to your picture, or you can say, okay, my 10 equals M, or my 5 square root of 3 equals N. All right, letter B, is it as easy as letter A? No, why not? Right. Which one do I have to find first, M or N? I have to find N first. How do I go from hypotenuse to short leg? 7 divided by 2. Now, if you want to leave that as 3.5, I'm fine with that. Okay, but I do not want your radicals to be turned into decimals. Capiche? All right, so if you had this as 3.5, I'm cool with that.
So on the test, if you leave it as a decimal,
As long as your radical's not in a decimal. Okay. Yes. Yep. So for N, we get that 7 over 2 or 3.5. How do I find M then?
It's times square root of 3.
Yep, so I take 7 over 2 or 3.5 times square root of 3. I want to go over this because this is a common thing that people do wrong. Can I do this? No. Treat this as over 1. So this turns into 7 square root of 3 over 2. Which, is this the same thing as if I multiplied this by square root of 3?
yeah.
It does get the same thing. Yep, so either one of those is fine. Now we're moving on to trig. Why is this important?
Because that's how we find the sides.
That's how you base the sides off, right? So circle your angle, always. I'm going from angle Z. Let's label our sides. What's 40? That is the hypotenuse. 32 is
Adjacent. Oh, opposite side.
opposite. 24 is adjacent. What does this problem want you to do?
Find the ratios.
Ratios. What does ratio mean?
This side.
Fractions.
Like over.
Fractions. Yep. So I'm going to start with sine. Sine of Z. Sine is
Opposite.
opposite over hypotenuse, which is
32.
32 over 40. Reduced by 8, and I get 4 over 5. What is going to be most helpful with the trig problems?
Oh, so.
Yeah. Do you know how to spell it?
SOHCAHTOA.
Bingo. Okay, so use that to help you out. Cosine Z.
Adjacent.
Adjacent over hypotenuse, so that would be 24 over 40. Divide by 8 again, we get 3 over 5. Last one, tangent.
Opposite over adjacent.
Yep, in that case, it is 32 over 24. Is it okay that we have a bigger number on top?
Yeah.
Yes. This gives us 4 over 3. Can I leave that tangent like this?
Yeah.
I can. Yep, you can leave trig as improper fractions. You don't have to turn that. Yeah.
If we forget to reduce it, is that wrong?
Yes. Yep, you want to reduce those. Yep. And can you just write 4/5, 3/5, and 4/3? Am I going to know what you're talking about? Just make sure. You don't have to show your work. Just make sure you tell me which one is which. Okay? All right. Now with 6, we are finding a missing side. For 6 and 7, there were the 4 steps that we followed. Okay, do we remember what step 1 was?
Circle your angle.
Circle the angle. Step 2, label the sides. What is our side X? Hypotenuse 20 is the adjacent side. Step 3,
Find the sine cosine.
pick the trig. Yep, that's my favorite thing to say. Pick the trig. Adjacent hypotenuse, what trig? It is cosine. So now step 4 is we're writing the equation and solving. So cosine of what always goes with the trig? The angle equals,
Swing over X.
does the order of this side matter?
Yeah.
Yes, 100% matters. On these ones, think cross multiply. Remember there was the tricks I gave you. If you want to go through the whole cross multiply process, you can. But what was the trick I told you? What's going to happen here? They're going to switch spots, right? So what's going to happen is you're going to have 20 over cosine 53. That, guys, what you type in your calculator. Okay, so for this one, you get x equals 33.2. And again, everything round to the nearest tenth. Now, if you ever, throughout the whole test, get domain errors or anything, 2 things to check. Did you pick the right trig? And did you put your ratio in the correct order? Okay, check those 2 things if you get domain error. Capiche? All right. Number 7, same process as number 6. What's the first thing we do? Circle the angle, and then label the sides. What's 6? Hypotenuse. 5. Opposite. What trig? Yep. Opposite hypotenuse. That is sine. Sine of x equals 5 over 6. Again, order matter? Yes. How do I get x by itself? You got to get rid of sine by doing the inverse. Yep. So what you should have is x equals sine inverse of 5 over 6. That guy right there is what you type in your calculator. What did you get for x on that one? 56.4. Again, if you ever get domain error, check the trig that you picked and check to make sure your ratio is in the right order. So at the beginning, we talked about all the junk, right? Do you agree there's a lot of excess information on number 8? Okay, what do I want you to read first? Question. Always go to the question first. It says it wants you to find x to the nearest tenth, blah, blah, blah. Is x an angle or a side? How have we been finding missing angles? With trig, right? The first thing we would always do is we would see, okay, if I have 2 angles, can I find the third? We know how to do that. But if we don't, that's where we're going to use trig. So you're going to use trig to help you out with this one. In order to use trig, what do you have to know?
The sides.
You have to know at least 2 sides, right? How many sides do I know right now? This one, and it is the what?
Base.
Yep, a base, and it's the adjacent side to that angle. Okay. So we need to find another side. I'm going to start here. Do I know anything about the hypotenuse here?
No.
I know absolutely nothing. Do I know anything about this side?
Yeah.
Yes. Okay. We have to do a little process of elimination here to find the missing side. Okay. So what I recommend is find this whole missing side first. You add these two together. So that gives me 7.9. Is this the length of this? People that are watching the recording, is this equal to this? You guys said no. Why? What do I have to do still? I have to take off that 0.75. So 7.9 minus 0.75, that gives you 7.15. And you can assume this is a right triangle. It tells you in the diagram. Okay. Now, do I have enough information to do trig? Yes. What is this side? That's the opposite side, right? So pick the trig. Opposite, adjacent. Tangent. Yep. So tangent of our angle x equals 7.15 over 5. Yep. And now we're going to do the inverse. So we do tangent inverse of 7.15 over 5. Type that guy in your calculator. You should get 55.
My calculator's messed up.
I'll help you. Should get 55. I did not round to the nearest whole number on this one. It ended up being like 0.98. So that made it round up to 55.
So if it is, so that number is 0.9 at the 10th, don't round it.
So for example, if it's 55.91, then this would just go to 55.9. But if it was 55.98, for example, then that would bump it up to 56. Yep. Number 9. Read the question. It says, how much fencing does she need? What does that pertain to? Perimeter. Yep. On number 9, even on the test, you are going to be finding the perimeter. Okay. What's the nice little hint that I gave you there? Law of sines. You are going to use law of sines twice to find both missing sides. Okay. So in order to know perimeter, we have to know every single side. This, in case we only know one, so I have to find x, and I have to find that side y. That's just what I'm going to label them for now. So this is where we start looking for relationships. Do you want to look for x and y at the same time? No. Okay. Let's just find x first. What does x relate to? 40. And then what's another pair I can relate it to? 13 and 49. Those are the two that I'm going to use to set up law of sines. I will put the equations back up here for tomorrow. Okay. So on this one, if I start with sine, what always goes with the trig? An angle. Yep. So if I just do sine of 49, what does that go with? 13 equals sine of 40 over x. How do I solve law of sines? Cross multiply here. Now remember, this 13 does not distribute to that 40. It just goes out in front. So this turns into x sine 49 equals 13 sine of 40. Right, and the last step to get x by itself is what? Divide that by sine of 49. So in your calculator, you are going to type in 13 sine of 40 over sine of 49. When you type that in, you should get x equals 11.1. A lot of you did this. Is that your answer? No. When you find something, what should you do? Fill it in the picture. So I get 11.1 for this side. I still need to find that other missing side. What are we going to do to find that missing side? Right, we're going to end up doing law of sines, but what he just talked about there is, what does y relate to? A, we don't know, but if we know two angles to find the third, Add them together, subtract from 180, you get 91. So y pairs with 91. Now, a really good question that I had is, does it matter which one of these I pick? What's the answer to that? It does not matter. I'm just going to stick with 13 and 49. But if you picked the other pair, it will still work out. Okay, so if I start with this, sine of 49 over 13 equals sine of 91 over y. Cross multiply. We get y sine 49 equals 13 sine 91. From Heather. What do you do next? Divide by sine 49. So you should have y equals 13 sine of 91 over sine 49. That's what you type in your calculator. So you get y equals, should get 17.2 for that one. When you find something, what should you do with it? Put it in the picture so you know what's going on. Okay, we're super close. How do I find the perimeter of that triangle? Add up all the sides. So if I come over here, we have 13 plus 11.1 plus 17.2. What does that give you? See, 41.3. And I did change the directions to the nearest tenth, so you're not getting confused. Okay, so this one you get 41.3. I will not be picky on labeling, so you don't have to worry about labeling it feet. Read the question first. What does it want? What does it really want? It wants x. Okay, so I'm going to circle what I want to find. Now, we talk about relationships. The biggest thing here is I'm telling you use law of cosines. Yes, I will supply that for you tomorrow. What does x relate to? 310. And I know the numbers are not as big as these on the test tomorrow. I know that was a pain. Okay. So those relate to each other. Those are the two you base your law of cosines equation on. Okay, so we start with that side, which is 310 squared equals, what are my b and c? Yep, 390 squared plus 220 squared minus 2 times those same two sides, yep. And then what ends it? Cosine of x. Some of you are putting sine in there. Don't do that. You'll get the wrong answer. Okay, make sure you're using cosine. Now, once you get it set up, it's just a matter of solving, which I know can be confusing at times. So I'm just going to go through. 310 squared is 96,100. 390 squared is that. 220 squared is that. What do I do with these three terms right here? Multiplying or adding? Multiplying, yep. So we get this guy, and then we have cosine x. From here, it's turning into an algebra problem. What can I do on that right side first? Yep, we're going to add these two numbers together. Can I include this one?
No.
Why not? It's part of cosine. It's multiplying with cosine. So we're just going to add these two together, and that will give us 200,500. And then I'm going to write what I have left. Okay. Now, our whole goal is to get x by itself. What can I do from here? Yep. I'm going to subtract this guy over. So we get negative 104400 equals here. Is it important to know if this is negative or positive? Yes. Okay, that's the most important part to keep track of. What's one of the last steps here? Yeah, divide by that negative. A lot of you are going to want to add this over, but why do we have to divide? Because it's part of cosine. Yep, we got to get it away from cosine. Do you remember what the most important part is when you get to this next step? You got to know if it's positive or if it's negative, the ratio. So this overall ratio right here, is that going to end up positive or negative? It's going to be positive. Do you have to reduce this? No, please don't do that. That would take you forever. Don't reduce that ratio. Okay. What is the last thing to do to finally get x by itself? inverse cosine. So you should get x equals cosine inverse of that big ratio. That is what you type in your calculator. So overall, you get x equals 52.5. Okay. Again, with calculators, if you have issues with calculators tomorrow, can you ask me those questions? Yes, I'm not testing you on how you use a calculator. Okay, if you know how to solve the problem and you're just struggling with your calculator, I can help you. Yes? All right. Questions on law of cosines. I'm going to tell you on this last one, there are two different ways you can solve. Okay? I did it a much harder way, and then I had a student say, well, can't you just do it this way? Yes, you can. Okay? So I am going to show you the preferred way to do it. Always go to the question. It says it wants to know what the area is of the concrete section. Well, do I know just from that what the concrete section is? No. So we go figure that out. Well, they're actually talking about the triangle. Okay, so we want to find the area of the triangle. Okay. Now, basic area of a triangle formula is what?
1/2 BC.
That's the trig one, but the basic one is 1/2 base times height. You guys like this one a lot better. Okay, so it tells us that this is a rectangular patio. What does that tell me about this triangle? It's a 90-degree angle. Yep. So we can assume that 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 triangle is a right triangle, which will help us because is there anything I can use that for to find something?
Yeah.
For example, can I find that? Put on the outside. This Pythagorean theorem, right? If I know if I know two sides, I can find the missing side using Pythagorean theorem. A squared plus b squared equals c squared. When you use Pythagorean theorem, what matters? What you put for c. So what can I plug in for a?
69.
Yep, 69 squared plus good x squared equals 115 squared. So we evaluate those. We get 4,761 plus x squared equals 13,225. What's next? Yep. So you get x squared equals 8,464. Last step always with Pythagorean theorem. Square root. You end up getting x equals 92. Did I even use this? Did I use the 100? No. Get rid of it. We don't need it. Like that. We can get rid of that. Okay. So overall, I want to find the area of this. Let's plug it into that. Looking for the area. I have 1/2. What's the base? 92. What's the height? 69. Yep. Why is 69 the height and not 115? Right. Remember, the height and the base are connected to that right angle. They're the two sides connected there. So remember, I know the difference between what the base is and what the height is because they are the two sides connected to that right angle. Okay, the hypotenuse is never going to be your base or your height. Okay, it's always going to be the two sides connected to that right angle. Okay, so what do I need to do with these three terms? Multiply all of them together. These three terms right here, multiply. When you multiply those together, you get 3,174. That is your area.